Determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So in this particular picture here, they tell me that AC is perpendicular to BD, so that makes a right angle. And we're supposed to decide if that's enough to say it's a rhombus. Well, the catch is, we've never proven that it was a parallelogram. It has to be a parallelogram with with the diagonals making perpendicular lines for it to be a rhombus. So there's really not enough information. And here's my argument. In a kite, those diagonals are also perpendicular. And this is definitely not a rhombus because if you'll notice here, these sides would not be congruent. So we have to be really careful. So what additional information do we need to know? We need to know that ABCD is a parallelogram. And once we know it's a parallelogram with the diagonals making perpendicular lines, then that would have been enough to say it was a rhombus. On number 26, let's go ahead and draw a picture because they didn't give us a picture. And let's go ahead and see what ABCD looks like because they're trying to get us to prove that ABCD is a rectangle. They tell me that AB is congruent to CD. They tell me that AC, this diagonal, is congruent to BD, which is an important feature of a rectangle. If it's going to be a rectangle, the diagonals need to be congruent. But we still need to know if it's a parallelogram. Well, they tell me that AB is parallel to CD. So actually, we do have enough information here. And let me tell you why. So we had one theorem that said that if you had a pair of opposite sides that were both parallel and congruent, this is a parallelogram. And now that we know it's a parallelogram, the diagonals are congruent, which is what makes it a rectangle. So yes, it's enough information. So on number 27, we're supposed to use the diagonals to determine whether the parallelogram is a rhombus, a rectangle, a square, and we're supposed to give all the names that apply. By look, this looks like it's just a rectangle, but we would need to verify that. So we want to first verify that it's a parallelogram. If it's a parallelogram, then the opposite sides would be parallel, meaning the slopes would be the same. So if we start at W and we go up 1, 2, 3 and go over to the right, 1, 2, 3, let's see if ZY is the same. Go up 1, 2, 3, over to the right, 1, 2, 3. Yes, so the slope of WX is the same as the slope of ZY. Now let's check the other slope. Here we've got going down 1, 2, 3, 4, 5, 6. I think I counted that right. Let me double check here. 1, 2, 3, 4, 5, 6, and then we're going to go over 1, 2, 3, 4, 5, 6. Let's see if X and Y do the same. Go down 1, 2, 3, 4, 5, 6, and then over 1, 2, 3, 4, 5, 6. So yeah, so the slope of WZ is the same as the slope of XY. So it is a parallelogram. Now that we know it's a parallelogram, we want to see, is it like a rectangle? If it's a rectangle, one of the distinctive features is that the slopes are perpendicular, or the slopes would be opposite reciprocal, because we'd have to have a right angle here. And so let's see if we can find a right angle here. And what we want to do is we want to look at that slope. Before this went down 6 and over 6, so the slope of WZ was -1. Let's look at the slope of WX. That was going to go up 3 to the right 3, which 3 over 3 is +1. So these slopes are both opposite and they're reciprocals of each other. So that does mean we have a right angle in there. What you'll notice is that we do have a rectangle here because of that, but it cannot be a square. And the reason is, if you look, we're going up 3 over 3, and if we use Pythagorean theorem to find the length of this, clearly the length of this segment is not the same as this segment, which already knocks out the square and the rhombus. On number 28, let's see which kind of shape we have here. So again, we want to check the slopes here to see if we have a parallelogram. So we're going to start with MQ, so the slope of MQ. and we're going to go down 2, 4, 5, and over 2, so it's down 5 halves. And then let's go ahead and find the slope of its opposite side, so NP. And we're going to go down 1, 2, 3, 4, 5 over 2, so that's the same, that checks out. So now let's go ahead and do the slope of MN. That's going to be up 2 and then over 1, 2, 3, 4, 5, so that would be positive 2/5. Now let's do the slope of this one here, QP. QP, we're going to go up 1, 2, and then we're going to go over 1, 2, 3, 4, 5, so that's positive 2 over 5. So what we have is we have the opposite sides have the same slope, so it is a parallelogram. And then the next thing we want to check is what kind. Well, if this is going to be a rectangle, then we would need a right angle, say like right here. And to do that, you want to just check the slopes to see if they're opposite reciprocal. If you look at these, this is opposite in value, this one's negative, this one's positive, and they are reciprocals. So we do have a rectangle. Now for this to be a rhombus, we would need all 4 of the sides to be the same length. So let's look at this in terms of like if we did Pythagorean theorem or the distance formula. If I did Pythagorean theorem, this has a side length of 2, this has a side length of 5. So that would be the idea of 2 squared plus 5 squared is equal to c squared. So that's 4 plus 25, so 29 equals c squared. So c is equal to the square root of 29. That means every one of these edges would have to be the square root of 29. Well, if you go over 2 this way and down 5 this way, you're using the same measurements, so that has a side length of square root of 29. If we go down 2 here and go over this way 5, and we do Pythagorean theorem on this, this is square root of 29. And then if we go 2 this way and then 5 this way and do 2 squared plus 5 squared equals c squared, that's square root of 29. So this is also a rhombus. Now because it's both a rectangle and a rhombus, then we are guaranteed that it is now a square because it takes on both features.